Scalar types. All scalar types are ordered, that is, all relational operators are predefined for their values. There are two types of scalar types, discrete and numeric. The discrete scalar types can be further divided into integer and enumeration types, and the numeric can be further divided into real and physical types. The integer scalar type is the discrete type that can possess any integer value between minus 2,147,000,000 and so on and so forth, and plus 2,147,000,000 and so forth, inclusive, i.e. a 32-bit signed. Something to consider here is that the leftmost value is the 2,147,000,000. When you define an integer and you do not pre-initialize it, or any data type, it will assume its leftmost value. So if you define an integer without initializing it, it's not unknown. It's set to minus 2,147,000,000. A natural number is defined as a subtype of integer, and it can be possess any value from 0 to 2,147,000,000 and so forth, inclusive. And again, it's defined as basically a subset of the data type integer. When you define a data object of type or subtype natural and do not pre-initialize it to a value, it's going to assume the value that's leftmost in the definition, which is 0. A positive data type is defined as a subset or subtype of integer as well, and it starts from 1 to 2,147,000,000 and so on and so forth, inclusive. Again, if you were to define a data object of type positive and did not pre-initialize it, you would assume its leftmost value, which in this case would be the value 1. An enumeration type is an abstract data type that has a specific number of options or identifiers listed as an ordered set, such as the type of a gemstone, i.e. a ruby, diamond, emerald, sapphire, or opal, or the suit of a playing card, i.e. heart, spade, diamond, or club. Here I've got a screen capture of the user-defined data types, card, suit, and gemstone. Card suit is heart, then spade, then diamond, then club. Gemstone is ruby, then diamond, then emerald, then sapphire, then opal. A data object that's instantiated with type card suit, if it's not pre-initialized, will be defaulted to the leftmost entry of heart, and for gemstone it would be ruby. Now, something else to consider here is that the identifiers are listed in ascending order from left to right. Given the above example, ruby is less than emerald, diamond is greater than spade, and sapphire is less than opals, or opal. The identifier names need not be unique. The identifier diamond occurs in both data types of card suit and gemstone. Which one is used is based upon the context in which it's called out. The data type Boolean is an enumerated data type which can possess the values true or false. It's defined in the library std, or standard package, and it's defined as shown in the screen capture there. Something else I want to point out as well, all relational operators such as equal or greater than result necessarily in a data type Boolean. Also, as with other data objects, if you define a Boolean and do not pre-initialize it, it assumes the leftmost value, which, as you can see, is the value false. The bit type is an enumerated data type which can possess the values 0 or 1. It's defined in the std standard library package, as you can see in the screen capture, and the default value for a data type or data object of type bit would be 0. Character data type is an enumerated data type as well, which can possess any of the values in the ISO Latin 1 8-bit character set. Severity level is an enumerated data type as well, which could possess the values note, warning, error, or failure. The type severity level is used to assert or report statements, which will be described later. It's also defined in the IEEE or the standard package std. A data object defined of type severity level that has not been pre-initialized will be of type note. The different values here are for basically serving different reporting issues. The default value, the value note should be used to pass informational messages only. The value warning should be used when a condition exists that may result in undesirable results. The value error should be used when a confirmation or a condition that will cause undesirable results, and the value failure should be used when a condition exists that should never occur. But we will cover each of these later when we talk about the assert and report statements and their usage. The real type is a numeric data type which can possess the values ranging from -1.0 times 10 to the 308th power to 1.0 times 10 to the 308th power inclusive. The degree of precision is only guaranteed to be 6 digits, but can be more based on the given tool set. Physical types are used to represent physical units of measure like time, mass, length, temperature, etc. Physical types are similar to real except that they also can contain units. Here's some examples of user-defined physical data types. The first is current. The range is same as the 32-bit signed integer from -2,147,000,000 and so on and so forth to +2,147,000,000. The units, the base unit is defined as NA or nanoamp. A microamp or UA is defined as 1,000 nanoamps. An MA or milliamp is defined as 1,000 microamps. And an amp is defined as 1,000 milliamps. There are also definitions here for the data types for voltage and temperature, and you can see how those are done as well. Time is the most commonly used physical data type that we'll probably end up using. It's defined as in femtoseconds, the base unit, which can be also from minus 2,147,000,000, so on and so forth. Same as a 32-bit signed integer, inclusive. It's defined as the base unit is fs for a femtosecond. A picosecond is 1,000 femtoseconds. A nanosecond is 1,000 picoseconds, so on and so forth. Up into an hour is being defined as 60 minutes. And it's also a data type that is defined in the STD package standard. The STD library also defines a subtype of time called delay length, which can possess anywhere from 0 to 2,147,000,000 and so on and so forth femtoseconds. The library also defines a function called now, which returns the current simulation time. It can be used to measure time between events so as to verify minimum and maximum time thresholds. It's defined, as you see in the screen capture here, as an impure function. Don't worry about what those are quite yet. We'll cover them in a subsequent session. We're able to alter the data type from one data type to another of an object via the same way that we might do casting in C, mainly putting the data type before the object and put the object in parentheses. For instance, real 123 would return an item of type real and a value of 123.0. Also, integer 3.6 would return a data type integer and be of value 4. Predefined attribute of scalar types. Attributes are defined in the library STD package standard. They return information about a type T by appending a tick and the name of the attribute itself, i.e. T tick attribute. The table here shows the attributes and their usage. For example, T tick left on any attribute type or scalar type returns same type as T, and it returns the leftmost value in T. There are also attributes for left, right, high, low, ascending, value, different things you can do, and the table here is provided for your reference.